A headline just went viral claiming Washington's most dangerous volcano is showing new signs of activity. People are already panicking. But here is the twist nobody's explaining properly. When you actually trace where these alarming signals come from, the real trigger behind almost every one of them is not magma. It's the weather. Stick with me, because by the end of this, you will understand exactly how storms, ice, and rain can fake a volcano waking up, and also the one real way weather actually can trigger a genuine volcanic disaster at this exact mountain. And if you want real science explained in plain language instead of internet panic, subscribe right now, because that is exactly what this channel does. Let's start with what's actually true right now, according to the people whose entire job is watching this volcano every single day. The volcano in question is Mount Rainier, located in Washington state, and it is officially classified as one of the most dangerous volcanoes in the entire country. The U.S. Geological Survey's Cascades Volcano Observatory publishes regular updates on it, and as of their most recent weekly report, the volcano alert level is set to normal and the aviation color code is green. These are the lowest possible readings available on the scale, meaning the volcano is behaving exactly the way it typically does. During that same reporting period, small earthquakes were detected at both Mount Rainier and nearby Mount St. Helens, but scientists were direct in stating that all of this activity is consistent with background levels, meaning it falls entirely within normal, expected behavior for these mountains. So if the official alert level says normal, why do these breaking news style headlines keep appearing, and why do they keep going viral? This is where the weather actually comes into the story in a way that most viral posts never explain. Let's start with the most direct connection. A real case where weather conditions on the mountain itself created a false alarm that fooled a huge number of people. At one point, a story went viral claiming Mount Rainier was showing increased seismic tremor activity, a phrase that sounds like a clear warning sign of an approaching eruption. This spread widely enough that scientists at the Pacific Northwest Seismic Network stepped in to directly investigate and respond publicly. What they found was almost the opposite of a geological event. The alarming signal had come from a single monitoring station positioned just west of the summit, known by the station code STAR. This station happens to be one of the last remaining analog stations still operating on the mountain, meaning it transmits its readings using an older, lower power radio signal rather than the more modern digital transmission systems used at newer stations. That older radio connection is significantly more vulnerable to weather-related interference, especially during storms. In this specific case, scientists determined that rime ice, which forms when supercooled water droplets in clouds or fog freeze instantly onto any exposed surface hit by wind, had built up directly on the station's antenna. Once that ice accumulated, it disrupted the station's already weak radio signal. When a receiver loses a clean signal like this, it doesn't just go silent. It often records the resulting static as if it were real ground motion, essentially creating a fake, jagged-looking seismic signal out of nothing but weather-related electronic noise. Scientists compared this to the static you sometimes hear on an old car radio when a station's signal starts fading in and out as you drive. In short, what looked like a dramatic volcanic tremor on a screen was, in reality, a weather event happening on top of a mountain, not a geological one happening inside it. To fully confirm this explanation, scientists cross-checked the data against a separate modern digital station called RCS, located about 2.5 miles to the northeast of the affected antenna. That nearby digital station, using a stronger and weather-resistant transmission method, showed completely normal low-level background activity during the exact same window of time. If a real seismic tremor had genuinely been happening inside the volcano, it would have shown up clearly across multiple stations at once, not just on a single old antenna that happened to be encased in ice during a storm. This is genuinely one of the clearest examples you'll find anywhere of weather directly faking a volcanic warning sign. The mountain wasn't waking up. The weather was simply interfering with one piece of aging equipment sitting exposed near the summit. Now let's move to the second major connection between weather and this volcano's headlines, because this one is a little more complicated, but it's arguably more important, since it involves a real earthquake event, not a fake signal. In July of last year, a genuine swarm of earthquakes began beneath the summit of Mount Rainier, and this one was not equipment interference. It was real seismic activity, recorded clearly across the entire monitoring network. Over its full duration, the swarm produced more than 1,350 located earthquakes, along with thousands of additional smaller events too weak to be precisely located. At its peak, it was producing roughly 40 earthquakes per hour. The average depth of these earthquakes was about 2.8 miles beneath the summit, and the single largest earthquake recorded during the entire swarm was a magnitude 2.42, far too small to be felt by anyone standing on the surface. Even though this swarm was real and substantial, the volcano alert level and aviation color code stayed at normal and green throughout the entire event, from beginning to end. That is a critical detail that a lot of dramatic headlines conveniently leave out. If scientists genuinely believed magma was rising toward the surface, an event of this scale would have triggered a higher alert level. It did not, because the underlying data simply didn't support that conclusion. So what actually caused it? Scientists explain that swarms like this one at Rainier have historically been linked to the circulation of fluids interacting with existing faults deep inside the volcano's hydrothermal system, essentially a network of heated water and steam moving through cracks in the rock, similar in basic concept to plumbing, just on a massive, naturally occurring scale, heated by the volcano's own internal heat, rather than by magma actively pushing upward. To directly confirm this, scientists conducted something that hadn't been done at this specific volcano in 27 years, an airborne volcanic gas survey. A helicopter equipped with specialized sensors flew directly around the summit, sampling the gases escaping from volcanic vents near the crater. This mattered because rising magma releases a very specific gas signature, and sulfur dioxide is considered the clearest indicator of molten rock moving upward toward the surface. The survey detected water vapor and carbon dioxide, both consistent with a low-temperature hydrothermal system, but did not detect sulfur dioxide at all. This matched the historical gas profile scientists have observed at Rainier for years and strongly supported the conclusion that the swarm was a plumbing event within the existing hydrothermal system, not a sign of magma approaching the surface. The precise GPS network used to monitor ground deformation, meaning whether the surface of the volcano is physically swelling or sinking, also recorded no unusual inflation or deflation throughout the entire swarm. When magma accumulates beneath a volcano, it typically causes measurable surface swelling as pressure builds underground. None of that showed up here. Within a few weeks, the earthquake rate gradually declined, and scientists confirmed that seismic activity had returned to Rainier's normal, decades-long average rate of about 10 earthquakes per month. Now here is where the weather genuinely does connect to this real event, even though it wasn't the direct cause of the swarm itself. Hydrothermal systems like the one beneath Rainier are influenced by the amount of water moving through the surrounding rock, and that water supply is directly tied to precipitation, snowmelt, and the volcano's massive glacial ice cover, which happens to be the largest concentration of glacial ice found anywhere in the lower 48 states. Changes in how much water is moving through the mountain's internal fracture systems, whether from heavy rainfall, rapid snowmelt during a warm stretch, or seasonal shifts in groundwater levels, can influence fluid pressure within that hydrothermal plumbing system over time. This is part of why past swarms at Rainier have been specifically attributed to fluid circulation rather than magma, and it's a reminder that weather and water are constantly interacting with this volcano's internal systems, even when there's no actual eruption risk involved at all. So, to summarize these first two connections clearly, weather can directly fake a fake volcanic warning sign, exactly like the ice-covered antenna that created a false tremor reading during a storm. And weather can also play a supporting role in real, but harmless, hydrothermal earthquake activity, by influencing the fluid systems inside the mountain, without that activity ever indicating an approaching eruption. Now, let's get to the third connection, and this is genuinely the most important one, because unlike the first two, this is a real, serious hazard where weather can directly trigger an actual dangerous event at Mount Rainier, completely independent of any eruption at all. That hazard is called a lahar, which is essentially a volcanic mud flow, a fast-moving mixture of mud, rock, ice, and debris that can travel down a river valley at speeds far too fast to outrun on foot. Mount Rainier is covered by around 26 major glaciers, more glacial ice than any other peak in the contiguous United States. That massive amount of ice sitting on the mountain is precisely what makes lahars such a severe risk here specifically. Nearly all of Rainier's largest, farthest traveling lahars throughout history occurred during actual eruptions, when volcanic heat rapidly melted glacial ice, creating a sudden flood of water that mixed with loose rock and soil as it rushed downhill. But here's the detail that connects this hazard directly to ordinary weather rather than eruptions. There is documented geological evidence of a large lahar that occurred at Rainier roughly 500 years ago with no known triggering eruption at all. This event, which avalanched from a location called Sunset Amphitheater on the volcano's upper west flank, is known locally as a no-notice lahar, because it can happen without any preceding eruption or obvious warning sign tied to volcanic activity. Scientists believe events like this can occur when weakened, hydrothermally altered rock on the upper slopes simply gives way on its own, and this kind of collapse can potentially be influenced or triggered by heavy rainfall, rapid snowmelt, or saturated ground conditions, completely independent of whether the volcano itself is erupting. That weather and water are constantly interacting with this volcano's internal systems, even when there's no actual eruption risk involved at all. So, to summarize these first two connections clearly, weather can directly fake a fake volcanic warning sign, exactly like the ice-covered antenna that created a false tremor reading during a storm. And weather can also play a supporting role in real, but harmless, hydrothermal earthquake activity by influencing the fluid systems inside the mountain without that activity ever indicating an approaching eruption. Now let's get to the third connection, and this is genuinely the most important one, because unlike the first two, this is a real, serious hazard where weather can directly trigger an actual dangerous event at Mount Rainier, completely independent of any eruption at all. That hazard is called a lahar, which is essentially a volcanic mud flow, a fast-moving mixture of mud, rock, ice, and debris that can travel down a river valley at speeds far too fast to outrun on foot. Mount Rainier is covered by around 26 major glaciers, more glacial ice than any other peak in the contiguous United States. That massive amount of ice sitting on the mountain is precisely what makes lahars such a severe risk here specifically. Nearly all of Rainier's largest, farthest traveling lahars throughout history occurred during actual eruptions, when volcanic heat rapidly melted glacial ice, creating a sudden flood of water that mixed with loose rock and soil as it rushed downhill. But here's the detail that connects this hazard directly to ordinary weather rather than eruptions. There is documented geological evidence of a large lahar that occurred at Rainier roughly 500 years ago with no known triggering eruption at all. This event, which avalanched from a location called Sunset Amphitheater on the volcano's upper west flank, is known locally as a no-notice lahar, because it can happen without any preceding eruption or obvious warning sign tied to volcanic activity. Scientists believe events like this can occur when weakened, hydrothermally altered rock on the upper slopes simply gives way on its own, and this kind of collapse can potentially be influenced or triggered by heavy rainfall, rapid snowmelt, or saturated ground conditions, completely independent of whether the volcano itself is erupting. Sometimes, like with the ice-covered antenna, it's pure weather interference creating a fake signal out of thin air, with no real ground shaking involved at all. Sometimes, like with the 2285 earthquake swarm, it's a real but harmless hydrothermal event, where weather and water may be quietly influencing the fluid systems deep inside the mountain, without any connection to magma or an approaching eruption. And in the one case where weather genuinely can trigger a real, dangerous event completely independent of any eruption, it's not through fake seismic readings at all, it's through the lahar hazard, where heavy rainfall or rapid snowmelt on saturated, weakened slopes could theoretically play a role in triggering a no-notice lahar, a genuinely serious threat that has nothing to do with the volcano waking up in the traditional sense. This is exactly why the real, responsible headline about this volcano isn't the dramatic new signs of activity claim that keeps going viral. It's this: the alert level remains normal. The seismic tremor scare was traced directly to weather interference on old equipment. The 2025 earthquake swarm was confirmed through multiple independent lines of evidence to be a hydrothermal fluid event rather than rising magma. And the one genuinely weather-connected hazard at this mountain, the lahar risk, already has a dedicated, functioning, decades-old detection and warning system specifically built to protect the communities living in its path. If you live anywhere in the Puyallup, Carbon, White, or Nisqually River valleys near Mount Rainier, the most useful thing you can do isn't panicking over the next viral headline claiming new activity. It's knowing your local lahar evacuation route in advance, since the entire point of the acoustic flow monitoring system is to give people enough time to reach higher ground once a real lahar is detected, but only if people already know where they're supposed to go the moment that alert arrives. It's also worth signing up directly for official USGS Volcano Notification Service updates, so that any genuine change in alert status reaches you the same way it reaches emergency officials, rather than filtered through a headline written to maximize clicks rather than clarity. Before we go further into Rainier specifically, it's worth understanding that this connection between weather and volcano monitoring isn't unique to this one mountain. It's actually a well-known challenge across volcano observatories worldwide. And understanding the general pattern makes it much easier to recognize when a specific headline is exploiting it. This is exactly why observatories increasingly favor digital transmission systems, like the RCS station used to confirm that Rainier's tremor scare was fake over older analog stations like STAR. Digital signals are generally more resistant to this kind of weather-related interference, though replacing every single aging station across an entire mountain range takes time, funding, and difficult logistical work, which is why a mix of both older and newer stations still exists across many volcano monitoring networks today, including Rainier's. This also explains why scientists almost never rely on a single station or a single type of data before making any official statement about a volcano's status. Cross-checking a strange reading against nearby stations, as PNSN did with the STAR and RCS comparison, is standard practice specifically because equipment can and does malfunction, especially in harsh mountain weather. A responsible monitoring network is built assuming that any individual sensor might occasionally produce a false or corrupted reading, And the entire system is designed to catch and correct for that through redundancy across multiple stations and multiple types of instruments working together. It's worth being clear about something important here too, since this is where a lot of confusion tends to creep in. The Lahar hazard at Rainier does not require an eruption to happen first, which is exactly why weather can play a role independent of any volcanic activity at all. Saturated ground conditions from prolonged heavy rainfall, or a sudden surge of meltwater during an unusually warm stretch affecting the mountain's glaciers, could theoretically contribute to slope instability on the volcano's altered, weakened flanks. The same kind of terrain responsible for the historic no-notice Lahar that occurred roughly 500 years ago with no known eruption trigger at all. This is fundamentally different from the seismic tremor scare or last year's earthquake swarm, both of which turned out to be harmless once properly investigated. The Lahar hazard is the one area where weather conditions genuinely do have the potential to contribute to a real serious event at this specific volcano, which is exactly why it deserves more public attention than either of the two false alarms that tend to dominate viral headlines instead. Let's also put Rainier into context alongside its neighboring volcanoes, because it helps explain why this specific mountain generates so much more public attention and, unfortunately, so much more misinformation than most other volcanoes in the country. So, practically speaking, what should someone living in the shadow of Mount Rainier actually take away from all of this? First, understand that not every alarming headline reflects an alarming reality. The fastest way to check for yourself is to go directly to the USGS Cascades Volcano Observatory's current alert page, which lists the live status for every volcano in the range. If Rainier shows normal and green, that is the official, real-time assessment from the scientists actually monitoring the mountain, regardless of what a headline or a social media post might be claiming at that moment. Second, understand the actual weather connection clearly, since that's the whole point of this video. Weather can create fake volcanic warning signs by interfering with monitoring equipment, exactly as it did with the ice-covered antenna during a storm. Weather can also quietly influence real, but harmless, hydrothermal earthquake activity by affecting fluid movement deep inside the mountain. And weather, through heavy rainfall or rapid snowmelt, is the one factor that could genuinely contribute to a real independent hazard at this mountain, specifically a lahar, which is exactly why a dedicated detection and warning system has existed here since 1998 and continues to be expanded and improved. Third, if you live along the Puyallup, Carbon, White, or Nisqually River valleys, know your local lahar evacuation route in advance and consider signing up directly for the USGS Volcano Notification Service so that any genuine change in status reaches you the same way it reaches emergency officials, rather than through a headline built to maximize clicks rather than accuracy. Real risk and genuine long-term vigilance around Mount Rainier are entirely justified, given its lahar history and its proximity to so many people. But that justified vigilance is a completely different thing from a false claim that the volcano is suddenly showing dangerous new signs of an imminent eruption because of one storm-damaged antenna or one routine earthquake swarm. Conflating the two only makes it harder for people to recognize a real emergency alert when one eventually does arrive, because repeated false alarms train people to expect nothing to come of the next one, too.